Science. This is Mr. B, and we are starting a new chapter today. The title of this chapter is energy. So this is a word, gets used a lot, probably has multiple meanings depending on what you're talking about it, but in terms of physical science standpoint, it's going to be directly related to work, which we, again, one of our main topics of our last chapter. So we're just going to go ahead and jump right into it. So the title of this chapter, which, remember last time that was the first question on our quiz, what's the title of the next chapter that we started? So maybe write down that simply the title of this chapter is energy, and the title of the first section within this chapter is energy and its forms. So energy can exist in a couple different ways, so it's not just like one one static thing. It's kind of ever changing and converting, which we will kind of get into a little bit later on. So as always, in our example, it talks about an avalanche. So in an avalanche, a mass of loose snow, soil, or rock will suddenly give way and will slide down the side of a mountain, and this avalanche is going to release a great amount of energy. And I think we've all probably seen a video of an avalanche, and I think it's kind of just obvious, just from kind of common sense, that a lot of energy is involved in this process. There's a lot of movement, there's a lot of forces acting in the same direction as a movement, so maybe there's a lot of work being done as well while an avalanche is going on. So, and I might maybe even ask you at the beginning, what's the sample at the beginning, and it is an avalanche. So I mentioned at the beginning that energy and work are going to be very closely related, so it's a nice segue between chapters here, because energy and work are very, again, kind of intertwined with one another. So energy is your ability to do work. So that's kind of their textbook definition. For energy, it's your ability to do work, and we're going to kind of expand upon that here in a second to kind of explain their relation a little bit more. And then another kind of key point here is that work is a transfer of energy, and I think this one is kind of the one where it really ties together, so you can really see how work and energy are really closely related, and it breaks it down even more on this slide. And oh look, it starts by saying what I just said, that work and energy are closely related. So energy is known by the types of changes that it causes, and so one example that kind of involves a change is work, and work is done when a force moves an object through a distance, which we just talked about that, because remember, when the object is not moving, there's no work being done. So work is done when a force moves an object through a distance, and while that force is moving the object through the distance, energy is transferred. So in that whole last chapter, when we talked about when is the weightlifter doing work, when is he not doing work, he was actually, while he was doing work, he was transferring energy through that dumbbell or that barbell, whatever he was lifting there. So energy is transferred by a force moving an object through a distance. So while work is being done on an object, energy is being transferred as well. So that's kind of how these two are really closely related. So while work is being done, energy is being transferred. When you guys made your machines, energy was being transferred through different machines as work was being done on your different simple machines. So that is kind of the connection between energy and work. I think that's really important, that while work is being done, energy is being transferred. And because they're so closely related, both work and energy are typically measured in joules. So that is our SI unit for energy as well. So don't have to learn a new SI unit for this chapter for now. So keep that in mind, that because they're so closely related, they're both measured in the same SI unit. So energy is kind of a big big concept, because it has so many different forms. Energy isn't really a simple thing that you can just wrap your head around. Said it's not static, it's very dynamic, it's always changing its forms and converting into different forms as well. Our main source of energy comes from the sun. That kind of drives everything on Earth. Without the sun, we wouldn't have any type of life here. So the sun gives off energy in the form of heat and light. Plants can harness that sunlight, and they can turn it into food. They turn it into food for themselves through the process of photosynthesis, for a little biology connection here. And then they also, plants kind of form the base of food chains, like they become food for other things like maybe the cow, and the cow becomes food for the human. So once the human inadvertently is going to get all of its energy from the plant, which inadvertently gets its energy from the sun, and then once the people have the energy inside their bodies, they convert that food energy into muscle movement. So the fact that your muscles are moving, the fact that you're taking notes right now, that you're listening, is all due to the fact that sun originally gave us energy. And that's kind of more of a biology topic, but again, physical science and biology do overlap quite a bit. So energy has different forms. From each step here, it's going to change into a different form. It's not being created or destroyed, which we'll get to that a little bit later on, and you've probably heard that before as well. But a big thing, energy has different forms. And one of those forms is going to be kinetic energy, which maybe you've heard this before. And this is the energy of motion. So when an object is moving, it has what is called kinetic energy. And hopefully that is not a completely new topic for you. I might not have gotten in depth with like solving kinetic energy problems, but hopefully you've heard that the energy of motion is called kinetic energy. And the kinetic energy of any moving object depends upon its mass, how much of there actually is, and its speed, how quickly or how fast is it moving. So those are the two big overriding factors within kinetic energy: how big you are, how much mass you actually take up, and what your speed is. And here's our equation for kinetic energy. It's 1/2 of your mass times your velocity squared. So if you double the mass of the object, it's going to double the kinetic energy, which that's pretty simple right here. So you just make this a 2, it's going to make that doubled. Make it a 4, it's going to double, so on and so forth. But if you're going to double the speed now, you're going to quadruple the kinetic energy because we have it squared here. And hopefully we all know, again, what an exponent stands for. We don't just take it by 2, we take it by itself. So velocity and speed have a much greater effect on kinetic energy than your mass does, because it's going to quadruple it rather than just doubling it. So we're going to do a sample problem here. We're going to do some more in class as well. So our sample problem is a 0.10 kilogram bird is flying at a constant speed of 8 meters per second. What is the bird's kinetic energy? So it's pretty simple. It's just laid out here for us. So first we got to get what information are we given. Hopefully we can figure out that they gave us our mass, which is 0.10 kilograms, and they gave us our speed, which is 8.0 meters per second. And what are we trying to calculate? If we go back here, it said we want to know what is the bird's kinetic energy. So we're trying to solve for the kinetic energy of the bird, which can be abbreviated as KE. And then the equation that we need is 1/2 mv squared. And so we plug in our information, 1/2 of 0.1 times 8 squared, and hopefully we know by our order of operations that we probably should do the exponent first. So we got to take 64 times 0.10 times 1/2. That's going to give us 3.2, and in the unit here, if we have kilograms times meters squared second squared, and that's just going to be a joule. So kinetic energy is measured in joules. And as usual, when we have some math problems here, actually it's going to ask us if our answer is reasonable. It seems reasonable because the bird has a low mass, so it would not have much kinetic energy. So this mass right here of only 0.1 is really going to drop down our kinetic energy. So 3.2 joules is actually quite small for our mass here. So we have a couple problems to solve like usual. So again, you can do these for extra credit, put them at the top of your quiz. So our first one, it says, is a 70 kilogram man is walking at a speed of 2 meters per second. What is his kinetic energy? So really similar to the last problem that they just showed there. So that's the first problem you can solve. Our second problem is a 1,400 kilogram car is moving at a speed of 25 meters per second. How much kinetic energy does the car have? So hopefully your number is probably going to be a little bit bigger in this one than what they were in the last one, because they have much more mass, much greater velocity here. And then our last one, a 50 kilogram cheetah has a kinetic energy of 18,000 joules. How fast is the cheetah running? Now, this one you have to solve for v, so you're going to have to rearrange your equation possibly a little bit. We'll go over how to do that, how I think the easiest way to do that is in class. But again, you can just go ahead and try to solve that one on your own. So that's it for our first one. Let me know if you have any